What's up, everybody? It's Chris Shabbat. I'm one of the SI leaders for Chem 1B. Today, we're going to be wrapping up thermochemistry by covering calorimetry. We're going to go over 2 example problems. So before we do the 2 example problems, I wanted to go over the 3 types of problems you should be ready for and prepared for come exam day. So what I call type 1s are 2 system without a phase change problems. So these are 2 different things that you're mixing where they happen to be the same state of matter. So you're mixing 2 liquids, 2 gases, or 2 solids. Now, the second type is a 2 system with a phase change problem. Now, this is 2 systems, but they're different states of matter. So you're mixing a gas with a solid, gas with a liquid, and so on and so forth. And then again, type 3 is just when you're studying a single system. When you do study a single system, you're not studying the transfer of heat, just the amount of heat that is required. So, and if you wanted help with type 3, we actually have a video posted about that earlier this week. So let's get into problem 1. So this problem is a 2 system without a phase change problem, and it reads 100 grams of water at 38 degrees Celsius is placed in 650 grams of water at 67 degrees Celsius. What is the final temperature of the mixture? So whenever we have these types of problems, we're going to be using CMAT equals negative CMAT. Okay, now we know that this side will be system 1, this side will be system 2. We'll call this system 1 and this system 2. If you happen to flip them, the math would still come out and you'd still get the right answer. So don't feel any pressure that you have to find which side is the negative side and which side is the positive side. So let's begin. We know that these are both liquid, and the C for liquid water is 4.18. So we have 4.18 joules per gram degree Celsius. Our mass for this side on the left is 100 grams. Now, our change in temperature is where it gets a little weird, right? Our change in temperature equals final temp minus initial temp. But we don't have the final temp. That's what we're solving for. So we're actually going to use a variable as a placeholder and say that's X. What's our initial temp? That's 38, right? Now for our other system, again, we're just going to put negative 4.18 joules per gram degree Celsius. We're going to multiply it by 650 grams. And then we have, again, we don't know our final temp, but we do have our initial temp on this system is 67. Okay, cool. Now, I could totally plug this into my calculator and then factor it in and then solve for X. I'm just going to make the math a little bit simpler and divide this whole thing by 4.18. So if I do that, I'll get something that just reads a little bit nicer. 100x minus 38 equals, again, we have to remember this negative is still there. We didn't cancel out the negative, so negative 650 x minus 67. So plug this into your calculator, you get 100x minus 3800 equals negative 650x plus 43550. Okay, now we're just going to add this over. So we'll get 750x equals 47,350. And our X here is 63.13 degrees Celsius. Now, the first thing you should do when you get an answer is check if it actually makes sense. So 63 is up, closer towards this temperature right here. But we know it has to be close to that temperature right there because we have so much more of that hot water than we do that cold water. So this does make sense and it checks out. So that's our answer for that one. So let's try the second problem. So now this is an example of a 2 system with a phase change. So now we're not mixing 2 liquids. We're mixing a liquid and a solid. So things get a little bit different. So let's read it. It says 75 grams of ice at 0 degrees Celsius is placed in 400 grams of water at 60 degrees Celsius. What is the final temperature of the mixture? So when we see these types of problems, it's no longer CMAT equals negative CMAT because we have to account for the phase change. Remember, if we look at the heating curve, there's that horizontal bridge that we need to account for now. So this equation is actually going to be Cmat plus delta Hg equals negative Cmat. And we'll say that this right here is system 1. This right here, system 2. This system 1 is now this whole thing. This whole thing is system 2. Okay, so now it's more so just a plug and chug. Our C, again for solid H2O, is not 4.18, it's 2.087. So we have 2.087 joules per gram degree Celsius. Our M is 75 grams. And our change in T, again, we don't know what our change in T is, right? So we have to do final minus initial, but our initial is just 0, so we're just going to put a 0 there. All right, now plus delta Hg. Again, we have to account for that phase change. So ice is going to have to cross that bridge and then enter the liquid range when we're looking at that upward sloping line. So we have to multiply our enthalpy of fusion, which is 333.6 times our mass of 75 grams. And then let me put the units here actually, so that way it makes a little bit more sense. This is joules per gram. We're going to multiply that by grams to cancel it out, so 75 grams. And so that makes the left side. Now on the right side, we actually have liquid water, so we're back to that negative 4.18 times our mass of 400 grams. Again, forgot to put units, joules per gram degree Celsius times 400 grams times, again, X minus 60 because we don't know our final temp. So now we have a little bit more to plug into our calculator, but everything should work out. If you do happen to plug this into your calculator, you should get 156.53x plus 25020. And that's equal to negative 1672 x plus 100,320. Okay, and then again, we're just going to clear it up so we have x on one side and then our value on the other side. If you do that, you'll have 1828.53x, and that equals to 75,300. Okay, now all we have to do is divide this side by 1828.53, and our x is equal to 41.18 degrees Celsius. Now again, just like the other problem, we want to see, does this answer make sense? So if I had, a handful of ice and I put it in to a big cup of hot water, what do you think is going to happen? That water is probably going to cool down a bit, and that's exactly what our answer tells us. If you guys have any questions about how these problems go, or Hess's law problems which weren't covered in this video, feel free to drop into SI office hours or comment down below and we'll make sure to get those questions answered. Thank you.